In this unit, we're going to be learning about functions, what makes a pairing a function, how to identify functions, and also how to identify the domain and range of a function. So first, we're going to do a little activity, and if you go into Google Classroom in the calendar, you'll find a decoder key, and so I want you to pause the video and use the decoder key to decode the message that you see here. Press play when you're ready to check your answer. So the message that we found is, let's have fun with functions. That's what we're about to do. So first, let's define a function. A function is a relationship between an input, which is going to be our x variable, and output, which is going to be our y variable, where for every input, you can only get one output. This is the whole key. For every input, you can only get one output. So here are some images below. Imagine this box as some type of math that's happening to your numbers. So you put the number in the box, something happens to it. Maybe you're adding 2, maybe you're multiplying, maybe you're doing something even crazier, and then you're taking a number out. If every time you put a number in, it's only possible to get one number out, then yes, that would be a function, because each input has only one output. In this example, we can see that we're putting in an input x, but we're getting out 2 different outputs, and so that would be an example that is not a function. So here's our question about the activity that we did with the coded note. Do you think the message you decoded above represents a function? Why or why not? This would be a function. It's going to be a yes. So our inputs in that note would be our emojis. These are what we're starting with. And what we're getting out using our decoder key is letters. So our inputs are emojis, our outputs are letters. Now the reason this is a function is because every emoji corresponded to only one letter. I'm going to say went just to make it shorter. And so what I mean by that is on my decoder key, I knew that if I saw the apple, the only possibility when I picked the apple was that that corresponded to A. If the apple could have been A or maybe even like G, then that would not have been a function. But every input, every emoji had only one possible letter it could be, therefore it's a function. We're going to do this with numbers really soon to make it mathematical. So some other vocabulary that you're going to hear regarding functions is domain and range. Domain is just the name given to the numbers that can go into the function, which the variable we're using for our input is x. The range is the name given to the numbers that can come out of a function, and so that's going to correspond with the variable y. So on example 1, it says, a rule says to multiply every input by 2 to get the output. Do you think this rule would represent a function? Why or why not? Well, this would be yes, because every input, every number that you put in, even though it's getting multiplied by 2, there's only going to be one possible answer. So every input will have one output. So for example, if my first x value going into the function box, so I'll draw my function box here, and so if my first x value, let's say was the number 1, well my function box is just saying to multiply by 2, that means that the number that would come out would be 2. There's only one possibility, 1 times 2, there's only one answer to that question. So no matter what this input number is, when I multiply by 2, it's always going to give me one answer out. So my domain, the possible numbers I could choose to put into the function box, would actually be everything. We could say for here all real numbers. Later on in the year, we're going to formalize this a little bit more, and we'll start to write it in a different format. But there's no restriction on what I can put into the box. Now, what could come out, since I'm multiplying by 2, I would expect the numbers coming out to be multiples of 2. So let's talk about the cost of gasoline. So say you go to the gas station and pay $3 per gallon of gas. What would be the price you would expect to pay for 3 gallons? You're going to write your answer here. What would be the price that you would expect to pay for 5 gallons? And do you think that buying gasoline that costs $3 per gallon would represent a function? Why or why not? If yes, we'll then talk about the domain and range. Pause the video to answer this part of the question. Press play when you're ready to check your answers. So for 3 gallons at $3 per gallon, I would pay $9. For 5 gallons at $3 per gallon, I would pay $15. Do I think this is a function? Yes. The reason is because there's only one possible price that you would pay for each number of gallons. If it's 3 gallons, it's going to be $9. There's no other possibility, assuming that we're all paying $3 per gallon. If it's 5 gallons, it's going to be $15. There's no other possibility. So that would be a function. So now let's talk about what the domain, which is our possible inputs, could be, and what the range would be. So in this one, if you think about up here where x could have been anything, remember that includes positive and negative numbers. But do you think it would be possible to buy any number of gallons of gas? And if you think about the number line going in both directions, we'd only be able to buy positive numbers. So this might be, if I were to write it as a list, I guess I could not buy any gas at all, and I could make it look like this. And it's going to go on forever. I could write this as an inequality by saying x, which is my, remember that's my domain variable or my input variable, has to be greater than or equal to 0. That's what this list is saying. Now, this list might be incomplete because here I'd be saying I have to buy 0, then 1, then 2, then 3. When you're buying gas, you actually can buy half of a gallon or decimals of a gallon. So this might be a little bit more inclusive. But again, we're going to kind of work to this. We're just trying to get the basics down. So then the range, again, would also be only the positive numbers. Now there would be multiples of 3 if my numbers were whole numbers. But again, maybe I'm buying, 1.5 gallons of gas. But what I know about my range, which is my y variable, is that it again is going to be greater than or equal to 0. Here's one that has to do with a backpack. So you find a lost backpack with the initials MS monogrammed on it. That just means stitched on. You're trying to find the owner. If the input is the initials and the output is the owner, do you think this would represent a function? Why or why not? So I'm going to draw my little box again. This time, my input is going to be my backpack, and the output would be the owner. So if you put in the backpack, does that mean that you're going to find the definite owner? If yes, then it's a function. If not, it's not a function. Think about it, say what you think, pause the video, press play when you're ready to check your answers. So for this one, I would have to say no, it's not a function, because just because the initials of the backpack are MS, that doesn't mean I'm going to find the owner. Maybe this person has the initials MS, maybe that's Michael Smith. Or maybe this person has the initials MS, maybe that's Marty Scott. There could be a lot of people who have the initials MS. So just because the backpack has the initials doesn't mean I'm going to find the owner. This input could have multiple outputs. So that's going to be not a function. Even though this isn't a function, we can still think about things that are going into the box, which are going to be the initials, and the things that are coming out of the box, which is going to be the owner with those initials. Let's do another example of square root. So a rule says to square root the input to get the output. So what that would mean is, here's my function box, or oops, I don't know if it's a function yet, so I shouldn't say that. So here's where something's going. I'm putting in a number, and when I put in that number, I'm going to do the square root. So let's say I put in 4. What would be the number that would pop out? Think about that for a second. I bet you're thinking 2, because the square root of 4 is 2. And you're accurate. 2 times itself is 4. So yes, 2 is the square root of 4. But is there any other number that if you multiply by itself would also get you 4? What about negative 2? Negative 2 times its exact self. Negative times negative would be positive, and 2 times 2 would be 4. So negative 2 is also a square root of 4. So when I put in 4 and I apply the square root, I don't know if I'm going to get out a 2 or a negative 2. So this would be an example of a non-function. So no, because each input would have 2 outputs. Now let's talk about Jetflix. Jetflix charges $9 each month, but the first 5 movies streamed are included in the price. You pay $2.50 for each new release movie you stream after the first 5. So we're going to write a function, which is just a new word for equation, to show the total cost that you would pay, y, based on x, which is the total number of movies streamed. So be careful with this one. Pause the video to write your equation. Press play when you're ready to check your answer. So this equation, to find my total cost, I would start by taking my $9 that I'm paying and adding to that $2.50 per movie. But remember, it's not for every single movie that I watch, it's after the first 5. And since X represents the total amount of movies, let's say, for example, you watch 7 movies total, that would mean that you're only getting charged for 2 of the movies because the first 5 were included. So I would first have to do 7 minus 5 and then multiply that by $2.50. You could simplify this equation, but I think it's going to be easier to look at if we leave it in this format. So go ahead and correct your equation now if you haven't done so already. Next, we're going to complete the table below to show the total amount paid depending on the number of movies streamed. So I'll get you started. For one movie, well, that's within the first 5, and so that means all we have to pay right now is that base price of $9. Go ahead and fill in the rest of your table. Pause the video, press play when you're ready to check your answers. So for movies 1, 2, 3, 4, and 5, we're paying that base price of $9. From there, it's going to go up by $2.50 each time. So for the price for 1, 2, 3, 4, and 5 movies streamed, it's $9. But let's see now what would be the output, our y, if we were to replace x with these numbers 1, 2, 3, 4, and 5 into this function. So I'm going to rewrite my function here. Y equals 9 plus 2.5. Remember, we have to do the total movies minus the first 5. And then let's just start with the number 1. So if I were to replace x with 1, I would do 9 plus 2.5 times 1 minus 5. And if I followed PEMDAS, I would first do 1 minus 5, which would actually be negative 4. Now, if I were going to multiply these together, which would be my next step, that would also be negative because a positive times a negative is a negative. And that would get subtracted from this price. So according to this function, if I were to watch one movie, my price would actually be less than $9. And that doesn't make sense because I already know that I'm paying $9 for one movie. This would also happen if the x value were the numbers 2, 3, or 4, because 2 minus 5, 3 minus 5, and 4 minus 5 are all negative, like it was here. And so that would affect the base price by making it go down. But we know that that doesn't make sense. So what this means is that my function isn't going to work for the values 1, 2, 3, and 4. Let's check 5. Imagine this number were 5. Actually, we don't have to imagine it. We can do it. So instead of x, I'm watching 5 movies total, but my first 5 are free. 5 minus 5 is 0. Anything times 0 is 0. And 0 plus 9 is 9. So if my input was 5, my output should be 9. Let's check our table. That's exactly what I wanted. So my function, which is this, y equals 9 plus 2.5 times x minus 5, doesn't start to work until the x value is 5. And so what this would mean is that the only x values that work would be 5, 6, 7, 8, etc. I could also show this using an inequality. Like I said, this is just kind of a preview, saying that my number of movies that I'm watching would have to be greater than or equal to 5. That just means in order for this function to work. Of course, if you're a member of Jetflix, you could choose to watch one movie. But this function will only be mathematically accurate if the x value is greater than or equal to 5. This is an example of how the domain works in the real world. Now, I didn't put range here, but we might as well talk about it. So range is going to be all the amounts of money that I expect to pay. What do you notice in your chart? The amount of money that you pay is going to be 9, and then it's going to begin to go up. And so, again, I could write this as a list, since there seems to be a pretty clear-cut pattern. Or I guess I could write it using a similar inequality, saying y has to be greater than or equal to 9. Domain always goes with your x value, range always goes with your y value. So in these next few examples, we're going to decide if the relationships represent a function. We're going to identify the domain and range, and if no, we're going to state which output has more than one input. So remember, to be a function, every number that goes into the box has to have only one possible number come out for it. So if we say no, then we also have to be able to point to the number that has more than one output. So let's look at this one. Here are my inputs, 0, 5, and 10. I can see that when I put in a 10, I get out a 3. Is there any number in this column that has more than one output? Yes. 0 could have an output of 2, or it could have an output of 5. So this would be no. Now I can still say domain and range. It's still a relationship. It's just not a function. So my domain would be 0, 5, and 10. Those are my inputs. And my range, which is my outputs, would be 2, 3, and 5. But again, the reason this was a no is because the input of 0 had the numbers 2 and 5 as outputs. So at this point, go ahead and pause the video, press play when you're ready to check your answers. I would pay close attention when you're done to number 9. So example 7 is a function. When you put in 0, you can only get out 0. 1 goes in, only a 2 comes out. 4 goes in, only an 8 comes out. 6 goes in, only a 12 goes out. So yes, it's a function, and my domain is 0, 1, 4, 6, and my range is 0, 2, 8, 12. On example 8, this would be a no, because when I put in a 2, the first time I get out a 0, and the next time I put in a 2, the next time I get out a 1. So if I were to put in a 2, I wouldn't know which of these two numbers would be coming out. So that's going to be a no. My domain is just 2, 4, and 7. Now you could say 2, 2, 4, and 7, but you don't have to say how many times these numbers appear. There's only 3 numbers that appear in this row, and they're 2, 4, and 7. Your range is 0, 1, 2, and 3. And so again, this was a no because the input 2 had the numbers 0 and 1 as outputs. Example 9 was the one I said to pay super close attention to. So this one is a yes, and you might be wondering why. Well, when you put in a 3, what's the only number that comes out? 1. When you put in a 6, what's the only number that comes out? 2. When you put in a 9, what's the only number that comes out? 2. And when you put in a 12, what's the only number that comes out? 1. Each of these inputs is only paired with one possible answer. So yes, it's a function. It doesn't matter that the outputs repeat themselves. That has nothing to do with a function or not. So this is a yes. Each input has only one output. Domain would be 3, 6, 9, and 12. And your range, you might have said 1, 2, 2, 1, but you only have to say what numbers you see appear here. And I only see the numbers 1 and 2. So you're buying concert tickets that cost $15 each with a one-time service fee of $10. You can buy up to 6 tickets. So first we're going to write a rule for the amount of money we're going to spend in dollars, and that will be our y, as a function of the number of tickets, which is our variable x that we buy. Pause the video, go ahead and write your equation. So our equation would be y equals $15 per ticket, so 15x plus 10. We've already been doing this, but now we're just doing it and calling it a function. We're just changing the language a little bit. What's the domain of this function? We're going to list all of the possible numbers of tickets that we can buy in the table. So it tells me that I can buy up to 6 tickets. I might have left one spot off the table. We can just add it in. So that would mean that my highest number would be 6. I'm actually going to add another column there. 6, 5, 4, 3, 2, 1. Now you might be wondering about 0. It is possible to buy 0 tickets. But remember, if you were to actually replace x with 0 in this function, what would be the output? 15 times 0 would be 0. 0 plus 10 would be 10. So what that would mean, according to your function, is that if you bought 0 tickets, you would still be paying $10. But you wouldn't pay the service fee if you didn't buy any tickets at all. So this function is only going to make sense for x being the lowest number of 1. Now let's do our outputs. So 15 times one ticket would be 15, plus 10 would be 25. This is our range. Then it's going to go up by 15 each time. 15 times 2 is 30, plus 10 is 40. 15 times 3 is 45, plus 10 is 55. I also know it's just going to go up by 15 each time. So if I want to, I can just add 15. This row would represent my domain. This row would represent my range. Okay, go ahead and try example 11. This time you're at a community center where art lessons are offered. The fee is $12 per lesson, plus a one-time art kit fee for $5, and you plan to attend up to 5 lessons. You're going to write a rule for your function, and you're going to enter the domain and range in the table below. Press play when you're ready to check your answers. So this time our function would be y equals 12x, because it's $12 per lesson, plus 5. If I'm only planning to attend up to 5 lessons, that would be my highest number, 1 would be my lowest number. So my domain would be the numbers 1 through 5. And my range would be the outputs that I would get for the costs for these specific numbers of lessons. So 12 times 1 was 12, plus 5 is 17. 12 times 2 is 24, plus 5 is 29. I could keep doing that, or I could notice that my y column is going, or y row is going up by 12 each time. This is my domain, and this is my range.